Those who do know me won't be surprised at all. I am a huge fan of Objective-Caml. I have talked about it many times as a great language to learn in and to explore basic concepts. So I'm going to fire up the interactive prompt here using UTOP, which is a little more advanced than the standard OCaml top-level environment. And let's look at a basic list. So there's one built into the language, but I'm gonna build one because it's just so easy. And I'm gonna make it polymorphic just for fun. Easy as that. There's a list. That's all you need. But we need some functions, of course. We can easily make, first off, let's make a list. So pretty simple to do. Just using integers just for the simplicity. Simple 2-element list. That's it. Simplest thing to do is probably to look and see if something, one of the simplest functions is, let's see if something is in a list. And that, we're going to define a recursive function because the data structure is recursive, so of course the function is going to be recursive as well. And I'm going to use mem because that's sort of idiomatic for a caml. You can call it whatever you want. And we're going to look for a value in a list, so 2 arguments. We're going to pattern match on that list, which is really one of the places OCaml shines. So if the list is nil, there's nothing in it, then there's no way you're going to find your value there, so we'll just return false. If it is some other thing or the rest of the list, because that's how a list is defined, then we just need to say v equal either v equals v prime, or is it in the rest of the list? There we go. Oh, and of course, syntax error because I got a little bit ahead of myself. So there we go. So now if we take that earlier, we can tab back up through the history, which is really, really convenient. If we take that and we look for 3, for instance, in that list, well, we know it's not there, but we're going to check anyway. Oh, as expected. If we look for 5, though, it returns true because it has searched through. Now, of course, the problem with any sort of thing on a list is you only know about the first thing in the list and everything else. Everything has to be linear. So searching if a value's in there one time, not a big deal. But if we want to find out if things are in there continuously, then really we need to start thinking about divide and conquer stuff. And then we start getting to, you talk about binary search trees and things like that. But we'll start with something simpler, like a merge sort. It's a very, very efficient sort and very, very easy to write in OCaml. So very easy to write something that merges 2 sorted lists. So we take our 2 lists, a recursive function, of course, and we're going to pattern match on those 2 lists very simply. Obviously, if either one is nil, and we'll call the other list LST in both cases because then we can just return LST. But if they aren't both empty, then we have to start getting a little more complicated here. So we're going to give the contents, bind some different names to the contents of those and say, so if x is less than y, then we're obviously going to put the x on the front of the list and the result, and the rest of the list will be the result of merging XS and list 2. Otherwise, the Y goes first. Pretty straightforward stuff. Oh, and there's an example of a place where I obviously typoed. I'm going to very quickly fix that. Very easy to do. But the problem is, where do we get the two lists to merge from out of one list? So we really need to partition a list into two. Now, the problem is we can't know how long a list is without going all the way through, and then getting the first half and the second half of a list is really tricky. But if we take and we sort of interleave them, so the first of the two lists is sort of the odd numbers or the even indexes, and the second half is the odd indexes. That is actually quite easy. And again, we're going to do some pattern matching. In fact, we can actually leave that explicit argument out and just say function. And if it's an empty list, then we're just going to get back two empty lists when we partition. That should be very straightforward. If it's a thing with one item in it, well, obviously, then we're going to get back that list with one thing in it and an empty list. If they both have something in them, though, then we start looking at, we need names for the first element in each and the second. And we're going to recursively call partition on the rest of the list, and I'm getting ahead of myself here. Actually, what we need to know is, we know we have at least two items, so we're going to pattern match this a little bit different. And so now we've pattern matched the first two items in the list and the rest, which could be an empty list or it could be something else. We don't care at this point. So we're going to partition the rest and stick it in there. So now we know what's happening with those, and we can just say that we're sticking the X onto the front of list 1 and Y onto the front of list 2. Oh. So OCaml infers types. So clearly, I've done something wrong here. Let's take a quick peek. I see. I'm so used to using regular OCaml lists that I used regular OCaml list literals instead of nil. And that's very simple to fix. Boom. Now our partition function works properly. So we can take a look and say, now if we do a actual merge sort on a list. So again, very simple. Obviously, an empty list is already sorted. There's no need to do anything further. A list with a single item in it, also already sorted. So, and I've aliased that pattern so we don't have to reconstruct the list. Not that it's a whole lot of work, but we're avoiding it anyway. But if it's something else, anything else, then now we need to look at. We're going to get the partitioned And if those are, so we're going to we're going to take a look and say, okay, if those are down to just one item, then obviously we can just merge the results of merge sorting list 1 and list 2, and we have a merge sort. So if we actually try to use this now, haven't written a whole lot of code here except for the times when I've typoed and screwed it up. We're going to look at, giving it a basic list here and make sure that our sort actually works. So that's pretty short, and sure enough, it's sorted. And that's basic divide and conquer, because we don't, the merge really isn't doing much. That merge is a very straightforward process going through. It's very quick, very simple. The partition is very quick and simple. Everything's very quick. We're not redoing lots of work. The complexity is very low to a merge sort, which is why, of course, they're used in standard libraries all over the programming world. So that's it. I don't have anything else for right now.